So I'm here with Reda Alhajj, joining us from Turkey. Reda is a researcher, academic, and explorer in data patterns, and he is also a professor at the University of Calgary. He's published over 500 papers. He's a referee in international journals and conferences. His interests are bioinformatics, data science, data mining, and social networks. He is the founding steering chair of a conference that's occurring this fall, we hope, in The Hague, ASONAM. So that's the International Conference on Advances in Social Networks Analysis and Mining. And he's also the organizer, one of the organizers of the BIDMA conference in Calgary that the DMC spring conference at UFC often runs around the same time. So Reda, thanks so much for joining DMC today to share your views.
Thank you for having me. It's my pleasure.
So on March 24th, Reda, to close out DMC's Fall Winter Series, you will be joining two other speakers in our event to talk about the very broad data science sphere. So in that vein, I'd like to ask you a couple of questions about data science and artificial intelligence. So this area of technology is quickly growing into the mainstream of data operations in organizations of all sizes. And it is being kind of recognized as a decisive competitive advantage when it's productionized successfully. What are kind of 2 or 3 areas that you recommend that organizations that are looking at starting that voyage, the journey down exploring AI and ML when they're just getting started? How should organizations, what should they focus on as they're just getting started?
So thank you for the question. Actually, I have been in this area for a long time. I started working with data since my grad studies in the 90s. And then I moved into data mining, machine learning, AI, because I realized that the trend is going in that direction. And in the past, people used to love computers because they allowed them to transit from manual process into automated process. Makes life easier, less errors, and they were happy in the 80s, 90s, having the relational databases, storing and retrieving data. Then they realized that storing and retrieving data is not enough. They want to dig down and mine the data, extract knowledge from the data, predict from the data. So they started to develop new techniques, new methodologies, and we get the data science, AI, machine learning, trying to integrate things together. But we are having all the companies trying to move into this direction. Some of them are planning, some of them are not planning. So if you look at this era, you may compare it to the era of the 70s and early 80s, where people used to learn how to write basic programs and claim themselves as computer experts, and they were developing systems in the market. And then the market started to suffer in the late 80s, 90s, that they had systems that they don't have any documentation about. They don't know how they were developed. They were developed by trainees and not by educated people. And they don't have good foundation. So I tell my students, you have to learn all of these data structures, algorithms, operating system, databases, because you have to learn these and integrate them all together into your career in the future. You cannot write good program without knowing the good data structures, good algorithms, development. So the same thing is happening now here in data science, in machine learning, AI. People think that if they learn Python, they will be experts and they will go on the market. So the companies should be very careful who they employ and how they employ. The universities are well prepared now compared to the 70s, 80s. Now they have developed professional programs where they educate people how to cover these new areas, machine learning, AI, data science. They have grad programs where they educate people, not train them. So we have to differentiate between trained people versus educated people. So companies have to go into employing educated people who know how to use the technology the right way and apply the right algorithms, the right tools. So not to be using the tool, but to know what is behind the tool. why we need the tool, because it's not that I want to use AI because AI is there. Do I need AI? What AI will do for me, and what techniques in AI will help me. So we have to integrate all these together. So we have to get people who are experts coming out of the universities, not coming out of their self-learning, because self-learning is dangerous and many times.
Totally agree. And actually, the comments on documentation were well founded as well, and also the integration with the business and understanding the business objectives. Because otherwise, if you're not working towards achieving a business objective, you're doing data science to an organization instead of with an organization. So this is how for example, adoption is meets the barriers. The second question.
Yeah, for example, now people are talking about big data. Now people are talking about big data and big data analytics, and they are talking about Hadoop, Sparks, and how we can analyze big data using Hadoop and Sparks. But there are many of those getting in this area. They are not differentiating between daily transactional data and real big data, because, for example, weather data is write once, read many. So it can be processed using Hadoop, using Sparks distributed system, but banking transactional data, which is always you update and modify, you cannot treat like the big data that they are talking about for processing in a distributed system, in a Hadoop infrastructure or a Sparks infrastructure. They are totally different.
Indeed, no, for sure. It's a totally different structure. So actually, that's a really great segue to the next question, and that is that the analytics landscape has evolved a great deal. It's been actually accelerated over the last few years. So I'm really interested from yourself as an academic, a researcher, and a practitioner, what methodologies, architectures, and technologies do you see kind of surviving the test of time in a modern and innovative analytics organization?
Okay, thanks for this good question. So first, we need to know what we are doing and what we want to do next. So we should develop the algorithms and the tools that we need, not that are required by the market. Because, for example, I should dedicate my time to develop things that the company that I work for will need. I should not get on the off-the-shelf things. Off-the-shelf things will never work all the time, because they can solve 80%, 90% of my problems. They cannot solve my problems 100%. So we should have adaptive systems that learn from the environment and try to adapt and expand as we go. So we should have incremental systems, tools like those developed by the key players now may not be beneficial in the future. So we should not stick to the existing tools. We stick to what we need and develop based on what we need. Mm-hmm. For example, relational databases were developed in the 80s, and still they are surviving because they have good mathematical foundation. Object-oriented databases appeared in the 90s, late 80s, but they disappeared then because relational databases absorbed their characteristics. Object-oriented databases were not having good mathematical foundation. Now, all these new technologies, they are good because they have good foundations. They have been incrementally built based on needs. And as you see, they are taking share from the existing technologies. They are not replacing the existing technology. Relational databases will continue to exist, but these graph databases, the data mining tools, different AI techniques will continue to appear, and we have to advance them as we need, and we have to know where is the need and direct our focus on that. Try to integrate, for example, multi-agent technology. Multi-agent technology is very good for distributed systems, for solving complex problems, where you break down the problem into small parts and try to have agents imitate the human way of thinking and try to operate Partial observability is a very important concept in distributed AI, because now the problems are all complex. You cannot see all the picture. You see part of the picture, you try to predict the rest based on what you see. So you have to integrate all these things. So knowing when technique is no more valid in this era. You have for a person, for a practitioner and academic to live in this era, they have to have a wider perspective, know how to integrate different techniques from different areas, and try to build hybrid systems that try to adapt to the needs of the organization. And no organization can get something out of the shelf.
Absolutely, it's about being practical. It's about choosing the right tool for the right time, and trying to stay blind to the hype. So
yeah, exactly. For example, IPM was dominating in the market in the past. You see relational database out of IPM. Then you see the technologies, mainframe came out of IBM. Many of the things came out of IBM. Then you get Microsoft in the play, you get Google in the play, you get Apple, you get many players now. Everyone is trying to develop, so the competition is higher. So we get better environment, more healthy environment for producing better outcome.
Indeed. Well, Reda, thank you very much for taking time out of your evening in Turkey to share your ideas with us on the 24th of March. We're looking forward to our session with you. And I wanted to thank you again for joining us today with DMC.
Thank you for having me, and I look forward to 24th of March.
Thank you, Reda.
Thank you. Have a good day.